Hello students, I hope you are good, well and fine, and today we will be discussing on the topic of functions. Okay, so in previous class, if you recall, we discussed what we discussed. We discussed the definition. What do we mean by function? Okay, let me recall you what do we mean by function. So first of all, function is a relation. Okay, relation from a set A to B. Okay, that's it. Then every element, so first, second, then every element of A must be associated to some element of B. Okay, that's it. And third is that the association must be the association must be unique. What this third point means? It means if A is associated to some element B, okay, and if A is associated to some other element A, this cannot happen because here the association is not unique because A is related to B also and A is related to C. This kind of thing cannot happen in functions. So functions strictly prohibit such things. Okay, so if you see pictorially or from the arrow diagram, if this is my set A, this is my set B, then suppose the element A and B1 B2 other element, if this happens, so this such thing cannot happen in function. So this is an example of not function. Okay, I'm giving you examples for not function. A and B, the set A and B, B1 and B2. Now suppose A1 related to this one. Okay, that's it. So is this a function? Also no, not a function. Why? Because here every element, if you saw from first point, that it's sorry, from this point, every element of A must be associated to some element of B. So here B is not associated to any element. It is alone. It is sitting just there without any link, any relation. So this cannot happen in relation. So this means this is also not a function. Okay, now, okay, I hope this is clear. Now, when we say a function, we say suppose A1, A2, B1, B2. So this thing can happen in function. Example of function. Why it is function? Because if you see that every element in this A set, every element in this A set is associated to some element of B. Yes, A2 is associated to B1 and A1 is also associated to B1. Okay, now the first points checked. Check second point. Second point says the association must be unique. This means this element must be related to only one element in the set B. Okay, so the association must be unique means every element in the set A has one and only one image in set B. Okay, image means these elements. We say these element as image. Okay, so B1 is an image of A1 and B1 is also image of A2. Here B2 is not related to anyone. This can happen in functions. Okay, but this cannot happen that any element here is not related. This can happen that element here is not related to some element in the set A. Okay, so I hope the 2 points are very clear to you pictorially as well as by statements. Okay, so now in today's class what we will cover is real valued function, identity function, constant function, polynomial function, rational function, the modulus function and the signum function, greatest integer function. We will cover these some basic functions. Okay, let's cover them. Okay, so first of all, what do we mean by real valued function? As the name suggests, it gives me the real values. Okay, so a function which has either R or one of its subset as its range. So the range must be the set of the subset of the real numbers or either R. Okay, then we call it as a real valued function. For example, if you see, for example, say my function is from set A to B, and B set is my A to B, and B set, say B set is my 1 2 3 dot dot 10. Okay, now my function is like this. So the say A set is my, I am saying set A is what, -1 -2 -3 dot 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 -10. Okay, now -1 gives me 1, -2 gives me 2, and so on. -10 gives me 10. So as you can see, the -1 is related to 1. The f, the relation f, the function f set will be what? Like this: -1, -1, -2, -2 till -10, -10. And we all know the collection of all the second elements in the pair, we call them as set of relation, sorry, set of range. So this is range. As you can see, the range set is what? Range set is my this B. So this means, and B is the subset of real numbers. Then I can say that it is my real valued function. Okay, I hope that it is clear to you. Now, further, if its domain is also either R or a subset of R, if suppose this set, the domain set and the range set, both are from the reals or the subset of reals, then it is my real function. So I hope that it is clear to you what do we mean by real valued function, real valued function versus real function. Okay, so real valued function gives real output, but input might not be real. For example, the input like complex number you can take like I gives 1, f of say f of 2i gives 2, f of 3i gives 3. So this, if I define relation like this, okay, the output is the coefficient of my this, just the imaginary part. Okay, so then this, in this way you can see that the input is not real, so but the output is real number. So this is my real valued function. So real valued function gives real output, but input might not be real. Okay, as definition says, the definition for real valued function only says about the range set. Range set means the output, the what we get after input. Okay, but real function says the output we get the output. So real function means output must be real numbers as well as the input. Input also real numbers, output also real numbers. For example, here, so the domain set, this set is reals, and the range set, as you can see, the range set is also from reals. So this is an example, perfect example for what? Real function. So I hope now it is very clear to you what do we mean by real valued function and real functions. Okay, let's move to next. Now, identity function. Identity function. So what do we mean by identity function? Quite easy. What it says is, if R be the set of real numbers, okay, then if we define a function f from R to R in such way that this is my function defined in this way, that fx is equals to x, whatever we are putting in the function f, we will get the same output. Okay, for every x belongs to the real number. For example, if you take x at 1, you will get 1. If you put 1.2, what you will get? 1.2. The same output you will get as the input. Okay, so this function, we called it as an identity function. So such a function is called the identity function. Okay, I hope that it is clear to you. Okay, let's move to next. Now, constant function. What do we mean by constant function? Constant function, as the name suggests, the function is constant, the output value is constant. So fx will be some constant number, some constant number, say c. Okay, so for example, fx defined like 2. Okay, for every x belongs to R. So this is my constant function, because when you put f of 1, what you will get? 2. When you put f of 0, what you will get? 2. When you put f of minus 1, what you will get? 2. You put any x, you put any real number x, the output will be the always same, 2, the constant number 2. So that's why the name here we used it as constant function. Okay, I hope that it is clear to you. Okay, let's move to next. Now, polynomial function. So polynomials, if you recall, what do we mean by polynomials? Polynomials is the expression like this: a0 plus a1 x plus a2 x2 till an xn, where n belongs to natural number. This is our polynomial expression. Okay, if an is non-zero, then this polynomial is of nth degree. Okay, I hope that it is clear to you. Now, here is my polynomial. As you all know that n is from natural numbers, or you can say non-negative integers. Natural numbers means non-negative integers. Okay, and all these coefficient of x, x square, and so on, these a0, a1, a2, an are from what set? The real number set. The real number set. Okay. So such type of function we name as polynomial function. For example, if you take example, fx is equals to say 2. Is this a polynomial function? Yes, indeed. Why? If you are saying that it is constant functions, yes, it is a constant function. Okay, so here if you see that where n is non-negative integer, means we are including the set of natural number plus the 0. If n is 0, then what you will get? You will get just this a0 term, and a0 is some real number. This means a constant number. So if n is 0, if, so here n, sorry for this little error. So the n from the non-negative integer, this means the set of natural number plus 0. Okay. So if n is 0, then what you will get? Then the function will be a constant function, but also a polynomial function. Why? Because it satisfies the every thing about the polynomial function. Okay, polynomial function. Okay, so if you take n is equals to 1, what you will get? You will get fx is equals to a0 plus a1x. Then such function will be what? Such type of function you will call them as linear function. Okay. Okay. If you take n is equals to 2, what you will get? You will get you will get quadratic expression, something like this. Yes. Obviously, we are taking a2 over here non-zero. If a2 is 0, then it will become what? Just a linear function. Okay. So it is now quadratic type of expression and so on. Okay. I hope now that you don't confuse with that. If someone asks that a constant function is a polynomial function, yes, indeed, when n gets 0, then the polynomial function reduced to constant function. Okay. I hope that it is very clear to you. Let's move to next. Okay. Okay. Now talk about rational functions. So rational functions are just nothing but type of such function, or the in here in numerator, this fx is from polynomial function and gx is also from a polynomial function. But here on g we restrict some things. Why? If you recall, in mathematics we always ignore to divide anything by 0, because it is not defined. Yes, so that's why we take this restriction that gx must not be equal to 0. That means gx not equal to 0 in x belongs to the domain of the function g. Okay, I hope that it is clear to you. If it gets 0, if it becomes 0, then what will happen? It cannot be defined. Okay, that's why but we need a well-defined thing over here. So that's why we restricted our gx like this. Okay, for example, if you take example, say your rational function will look like this: x minus 1 by x plus 1 for this is my fx, say fx or say hx is equals to x minus 1 x plus 1, where fx is equals to x minus 1 and gx is equals to x plus 1, but g the domain for g is, but the domain for g is what? The domain for g is all real number except minus 1. Why we are not taking minus 1? Because when you put minus 1 over here, what you will get? You will get the denominator equals to 0, and this is strictly prohibited. Why? Because it is we already defined fx and gx in such way that the gx must not be equal to 0. So that's why we took the domain of g in such way that gx cannot happen or cannot give the output equals to 0. Okay, I hope that it is clear to you. Okay, let's move to next, the modulus function and the signum function. Okay, now the modulus function. Modulus function, the defined as like this: fx is equals to mod x. So modulus, this means the modulus function is nothing but what? It gives positive or a positive output. It is always positive. So always positive. Okay. So the another way to define the modulus function is modulus function. The another way is like, one way is this, the another way is this. If x is 0, then you will get, put x 0 over here, what you will get? 0. If x is positive, you know mod function always gives the positive value. If you put any positive number over here, suppose you put 1, what you will get? 1, you will get output 1. You put 0.1, what you will get? You will get 0.1. You put 100, 1000, anything, any number you want, you will get the same number if the number is positive. So this means the output will be x. If your input is negative, suppose if your input is negative, if input is negative, if input is positive. So if input is positive, then the output will be the same number. If input is negative, then what we will be getting as our output? Let's see. So if input is negative, suppose x is some minus 1, the output will, we know the output will always be positive. So the correct answer for this is like this. What you will get? You will get, indeed you will get 1, the same answer as this, but you will have to what? Multiply with minus sign over here. Or what you will get? The output, indeed you will get the output as this, but after multiplying it by extra minus over here. So that means whenever you have negative input, then the output will be minus of that negative number. Okay. For example, we have seen over here and over here. So this is the another way to look at it. So the diagram, if you look the diagram looks like on the Cartesian plane is like this V, modulus V. So 0, this is my x and this is my minus x. The equation for this line, the equation for this line is minus x and equation for this line is plus x. Okay, and this graph is symmetric to this y axis. Okay, so this is my modulus x graph. Okay, I hope that it is clear to you. Now the Signum function, what it says? Signum function says if f defined from real number to real number, defined by in this such way that if x is 0, then you will get the output 0. If x is positive or the input is positive, what you will get? Output as 1. If input is negative, then what will be your output? Output will be your minus 1. So let's look at the diagram for this Signum function. So Signum function, when x is positive, so this is my 0, this is my positive x-axis, yes, x. This is my negative x-axis, negative x-axis. Okay, this is my positive y-axis, and this is my negative y-axis, Okay, let's draw. So when we are here, suppose this is my some positive x, then what will be my output? My output will be just the 1, like here. If I am here, my output will be here. If I am here, my output will be over here. So this, but at 0 my output is what? At 0 my output is this. Here the little open circle will be there because it shows that at 0 the output is not 1, because it is open says it is not 1. Okay, then it goes to this direction. If now I am here at the negative side of x-axis, suppose this is say what? It is a minus 1. Okay, then output will be what? Output will be minus 1 here. If I am standing over here, say minus 2, the output will be still minus 1. Whenever we have negative input, we always get the same output as minus 1. So this means in this direction we will be moving. Okay, so my final graph for this Signum function will look like this and this. Okay, so at 0 we got 0. At any positive x number we will get plus 1, and for any negative x we will get minus 1 as our output. So the graph for Signum function will look like this. Okay, I hope that it is also clear to you. Now let's the last function for today's class is greatest integer function. As the name suggests, greatest integer function, we denote greatest integer function like this. Okay, what it gives, for example, first of all let me give you the definition. It assumes the value of greatest integer less than or equal to x, such a function is called the greatest integer function. For example, if I write 1.5 over here, then my output will be what? Less than or equal to x. The greatest integer less than or equal to x. What will be the greatest integer less than and equal to 1.5. What? It is just 1. Yes? For 0.5, the greatest integer which is less than 0.5 or either equal to 0.5, it is 0. Yes? And if you take the -1 example, so -1, the less than or equal to the integer -1, what it is? It is itself -1. If 1, what you will get? 1. If you get minus 0.5, then what you will get? The greatest integer but less than -0.5 or equal to -0.5. What it is? It is -1. Yes? Okay. So this is the way that we define our greatest integer function. If you plot the graph for it, let's plot. So if you see the interval from 0 to 1, say 0 to 1 interval, and interval from 0 to -1, we know what we know, that take any value in between 0 to 1, such as take 0.5, take 0.6, take 0.000001, anything, but less than, I am taking value less than 1 but greater than 1. Okay, then my output will be what? 0, because the greatest integer less than 0.5 is 0. Here it is also 0, 0 and 0. Okay, so my output will be this 0. Whenever x is what, my output always be 0. But what about at 1? If input is 1, what I will get as my output? I will get my output as equals to 1. So this means at 1, my output will be like this, 0. If you see in the interval 1 to 2, 1 to 2, 1 to 2, take any value in between 1 to 2. For example, 1.2, 1. Say 2. What you will get as your output? Always get 1. Okay, so 1.99, you will still get the output as 1. So like this, you will get the output as 1. Okay, but at 2, what you will get output? 2. At 2, what you will get the output as 2. But if you see at the negative axis, or when the input is negative, what you will get? The output, suppose minus 0.5, your output will be -1. If minus 0.6, the output will be still -1. Okay, so for negative value of x but less than, the value must be the input value must be less than -1 and greater than less than 0 but greater than -1, like it can be here, your output always will be -1. So the output will be what? The output will be this, -1. Okay. So I hope that it is very clear to you. So if you look the overall picture for this greatest integer function, your graph will look like this. So your graph will look like this. At 0, it is 0. At 1, it is not 0, it is actually 1. At 2, it is not 1, it is 2. So like this, your graph will be something like this. This is my -1, -1. Okay. At -2, -2, your graph will be like of staircase. Okay, jump. Okay, So I hope that it is very clear to you that how I plotted the graph for it. I hope that every function we discussed, the graph of them is also clear to you. So that's it for today. Thank you. We will meet next time. Thank you.